was nice on
The sky.
the sky. Right, go right cloud. Like, what goes through your mind when you like sky? So when you get like your data are saved in the cloud, how does it? Have you ever imagined that kind of? How does that work? Like your data are saved in the cloud. Do we have any idea? Can we see? Let's have some say.
They just want to ask me that too much data is going to be in the cloud too. All those things.
Too much data is going to the cloud, right? Okay. So if you have heard about cloud and cloud computing, if you have a little bit idea, can we have? Let me know so I can go to the simplest. Okay, we don't have 3 people that have a little idea. Okay, 4, you are 4, so I can actually go down more. Okay, nice, awesome. So next slide. So how cloud computing is actually amazing. As you can see, a very young man without a face, no face, I don't think it was pointing into your computer. This is a computer, and you have your mailbox coming in from the cloud, and you have your other things, other things coming in the centralized area. Let's look at the second picture. Where video shows like cloud at the middle of them all. Your phone, your network, your Hypernet, your NPS, everything interconnected into the central cloud. So we have a picture in this area. So what's this picture like? What do you say? Can somebody tell me about data center? Anyone? Data center? You said they said this is data center, isn't it? Who said that? Nobody is so confident to that. So you want to talk? Let's have you. You want to talk? Can you explain why a female? Just one female. Let's appreciate that, please. So what's
My name is Faith.
okay, nice.
That's a data center. That's the different data center. It's a cloud, I'll call it that.
Okay, let's appreciate this. Okay, please let's appreciate that again. Nice. So this data center actually is actually running. That's where all our data are being stored. So when you heard about cloud is not just the cloud we see. It's not where the birds are flying actually. So we have a physical place is called a physical location called data centers.
That's where the data is stored.
So your data are being stored in physical device with the server, and you can see our data centers are very, very cool just because the kind of processor CPUs and everything they use. You can't imagine. One of the largest data centers in the world is made by Google. They connect like 3 waters from one from Los Angeles and one from 2 other areas. Actually cool data centers, which is actually really amazing. So you can follow me on Twitter. I tweeted about it. So I think we are both around that. So let's talk about cloud generally. So we have cloud. I know if you're familiar about AWS. Anyone? AWS mini, full mini AWS. 1, 2, go.
Imagine.
Okay, nice. So, who's this? Who has Azure?
Microsoft.
Okay, nice. So I think we're more familiar about cloud, which makes it more awesome. So you can see. So we have the Amazon Web Services. So who can tell us the virtual assistant for Amazon? That cloud thing that talks to you. Really?
Alexa.
Come on, please let's appreciate it, Alexa. So for Microsoft Azure, so what's that virtual thing that talks? Cortana. So for Google, what's that virtual thing that talks? Google Assistant. Awesome. So we have 3 clouds.
This is the first one.
Alexa. So who does Siri goes for?
iOS.
Okay, nice. So you can see we have the AWS web services. These are things that are actually connected. And if you talk to your Google Assistant, like Alexa, Siri, or Cortana, everything, you see that it picks all what they do. They have been configured via the cloud, and they have their own private data being stored. And you see that the other sites that they actually code through. If I don't know if anybody has gone through build actions. If you've gone through conversational actions and all that, so you can see that they have different kind of replies, responses they can give to you. Once you ask a simple response, they have like 10 to 20 responses stored concurrently in the cloud. They pick the most accurate, similar to your keywords which you give them. You say, Google, how are you? You can tell you, I'm fine, maybe today I'm learning new languages. But if you ask it some other time, it will tell you another answer. It doesn't have to be repeated the same thing. So we have Amazon. A lot of people have Amazon Web Service, which give you some certain amount of the cloud and uses to host your website, your applications, and all that. So as Microsoft Azure, and same time Google Cloud as well. But today we're going to focus. My case study for today is what I'm going to talk about. We have three of them. We have logos of different Azure and all that. So both of them do it awesomely. Trust me. Amazon is an amazing cloud platform. Azure is an amazing platform. Google Cloud as well is an amazing cloud platform. But I will tell you the reason why I'm focusing more on Google Cloud platform today. So Google Cloud platform, you can see, is designed for IT professionals. Basically, like you can be professional in every aspect. But you plan integrating, migrating, and maintaining. It's actually very important. You are deploying your software, you're migrating your software, you're integrating from one platform to another, you're doing via APIs or anything, or applications, and you're putting your applications in the cloud. And why are you putting your application? The question is why? Why? So, why are you putting your applications in the cloud, isn't it? So, you see, there's two things about cloud that are most essential that you have to know. And the first thing is performance. And the performance goes with pricing. So another thing you see why you see people do more of their stuff in cloud is performance, scalability, and what speed. You can put your hostings on normal shared hostings, virtual hostings, web shared hostings. You can do all those things. But when you're on cloud, it's exceptional, different, because you are being created, your own CPUs are being created, just like you having your own virtual machines, like your own computer, this station, rather than you having on a web share hosting whereby you have like 10 people connected to a computer. You can't imagine a computer. And another scenario is you have a website that 10 people are accessing, compared to a website where 100 people or 1,000 people are accessing. The speed and performance, how is it going to be? It will vary, isn't it? One will be slower and one will be faster. That's how cloud is. If you build applications on normal web hostings like Go Hosting, QSarra, GoDaddy, Bluehost, they are all web shared hostings. You can see a lot of people using the same hosting that you are using. But you're on your cloud, you're creating your own virtual computer, which stimulates you from differently. Do you understand? And at the same time, as your application is getting bigger, you see that you can automatically adjust it. As your application is getting, maybe you have about 100 users before, 500 users before, but now you're having about 2,000 users, 5,000 users, 1 million users. Immediately, your cloud will be extending and be automatically scale to fit in for those people that users are coming in, give them space, performance, speed, and your application works perfectly well, rather than when you're in the web hosting. Jumia for a while was on normal web hosting. It's of recent when they're about to move their accelerate to New York and they can't be on that hosting platform, they have to move to the cloud. And about that was affecting them because they have a lot of users, millions of users accessing Jumia. So they have to move to the cloud so that they can have better performance, better speed, and scalability at the same time. So you can see some people are afraid. So why Google Cloud Platform? Google Cloud Platform is GCP. So why GCP? Some people are actually afraid of bringing their stored to the cloud, deploy, the driver will just be logged out in the cloud. And when you are in there, your applications, your billing, it's the simple case, your billings are really, you can't predict your billings. So when your application is coming, when you're actually building your applications on this cloud, you have to be very careful with your billing. So why do you see that people hire cloud experts? Why do you see the speed? They need to understand in and out of how the cloud platform works so that they can spend less on the cloud. So you will not run into them actually. So Google is flexible enough for you to provide some that gives you customers ability to run their cloud applications elsewhere. You can migrate from maybe AWS, Amazon Azure, Microsoft Azure to Google Cloud. You can at the same time, if Google platform is not convenient for you, you feel it's not what you want, if it's not your, they are not serving to the this kind of service you actually want any longer. So you see, why CPI said GCP services are compatible with open source projects. We see like open source projects, like who has learned about TensorFlow, machine learning, the open source projects on cloud, which is amazing. TensorFlow. So it's an open source platform for you to provide things like machine learning, for you to provide things like face recognition, object recognition, and all that. So TensorFlow is an amazing thing, like open source projects on the cloud platform. We have another one. It's many GCP technology provide interoperability. But I was telling you, you can move in, you can move out, you can scale, you can move in from Amazon to Google Cloud Platform, and show to Google Cloud at the same time. So another thing is Kubernetes. We still learn about Kubernetes. Kubernetes actually is another awesome cloud category that you're supposed to know if you are into cloud. But very complicated at the same time. You have to really understand Kubernetes. I was thinking go to Kubernetes. So Kubernetes gives customers the ability to mix and match microservices running across cloud. If you have a microservice business and you're running, you work with containers, and if you can manage the containers very well, just like the example that our first was giving, you understand. When I get to Kubernetes together, so we start there and lets customers monitor workload across the multiple cloud providers as well. So you can see why GCP is actually amazing. So it allows you to compute storage based on big data, the machine learning, and application service for web, mobile, analytics, and even mobile banking, which you actually use. So GCP is global. Yes, it's global. Though we don't have a GCP station in Africa. We have anyone, though we don't have in Africa, but trust me, you can connect. So you can connect based on recommendation. At the same time, some recommendation gives that you connect based on the fact the closest continent to you. You have in Asia, you have in Europe, you have in the US at the same time. So depending on where you did your cost, you can say, oh, I don't want to spend more than $20 per month. I don't want to spend more than $24 per month. So make sure you can set controls on your costs on Google Cloud. You can adjust it and all that. There's an open source friendly as well, and it's designed for security. You can tell, hey Google, I want you to manage my security for me, from low level to mid level, then high level, I can take it all for myself. So see, cloud is more secure. That's one of the major things why you do. For those that use WordPress, easy to hack, you build on WordPress, you can show WordPress for more security, put it on cloud. It actually encourages that it actually protects your website. You have application very more, and you enjoying it. So in GCP, Google Cloud Platform, we have what we call Google Cloud Console. So Google Cloud Console is just like GUI. What do I mean by GUI? Graphic User Interface. It's just the graphic user interface, the interface in which you operate and control your what, you control your every interact with your GCP. So basically, what you do on the GCP is allows you to interact with GCP. You can access your cloud here via it. You can go compute engine, your app engine, your Kubernetes. You can access them via the GCP. But this is different channels you can interact with your cloud platform. You can use console that I told you, cloud console. Then you have the XDK and the cloud share. The XDK and the cloud share, I'll go there, is something, is the command prompt area of you accessing the Google Cloud. You want to code it in the command prompt in the virtual environment, then you can do that. And the mobile app is another one, and the API as well. So the first one is just by web-based administrative interface, which you use just like MDP, where you access your stuff. I'll show you the diagram of it in my next slide. So in the cloud share, I told you, is a command line interface, GCP, that's easily accessed from your browser. So you can code the command lines without even using, for when you access to the web. Another one is Google Cloud set of tools that manage the resources applications. So you can actually use the GTL as well via your SDK and some other key components. There should be other applications programming interface as well. That's the APIs. So you can access them from outside your API, right? Your API is connected to the RESTful. Then the RESTful API, then you are good to go. Then the mobile app versions for Android and iOS, you can download it online on mobile app. Let's examine and manage your resources. You don't necessarily have to be on your computer. You can manage your resources via your phone. You can see it. You can let it be your dashboards, get information at a glance. So you can actually use those to interact with the cloud, with the Google Cloud. So cloud share. So you can see in this is the Google Cloud console that I was telling you about. So this is Google Cloud console. So the Google Cloud console, this is how you able to see your home, this is your marketplace. You're looking for maybe to install a server, or a PHP server, or a node server. You can see the marketplace, you can see the billing there, you can see the API, the support, the hiring, and the privileges and the admin aspect. Then getting started, you have the security, then you have the computing. The computing is when you want to compute, how you want to build your what? You want to build your Google Cloud. So you can build your cloud through these mediums, either through the app engine, the compute engine, the Kubernetes, or the cloud functions. At the same time, if you scroll down, you see the storage. The storage. So on the storage, you see the SQL. You see the SQL. Well, they call it SQL, but we call it SQL. SQL is saying that SQL. So you can actually have your SQL in that aspect, cloud functions and everything, which we're going to talk about in the next slide. So am I communicating? Okay. So here is Google Cloud Platform. Here is Google Cloud Platform. This is what you buy. So the first one that on my slide is what the compute engine. The compute engine is just virtual machines. I'm going to explain in the next slide. We have the app engines. The app engines use the BigQuery, the cloud data flow, and the cloud QB and so as well. Then in your cloud functions, you have the cloud data store, cloud file store, cloud storage, and the Kubernetes, you have the containers and the cloud auto machine learning as well. So this might a little bit sound advanced, but trust me, you have the knowledge of how cloud works, and you have the insight of the cloud you have been learning, you have been hearing, and how the thing works, and why you should be a part of using cloud as well. I'm going to explain in my slides, I'm going to see for them. So in this serverless aspect of it, okay, I think I've explained this. So inside the serverless compute aspect of it, we only have two of those functions, which is the cloud functions and the app engines. The compute engine does not have the serverless areas. And so the cloud functions are event-driven serverless compute platforms. And I will give examples of software and the appropriate apps that you are building, either you're building a financial app or you're building a normal small web apps. The exact one thing about cloud is that if you don't use the exact platform or to compute your cloud, you're going to miss out on it. Either you have a higher scaling or you don't necessarily think on cloud. You have these ones that are meant for only just backups and storages. You have these ones that are meant for only building financial applications, all works on it. So you have to understand how they all work. So the app engine. So the app engine is a fully managed platform as a service framework, which means you clone in cloud without having to worry about the infrastructures. You don't have to worry about the infrastructures.
Before you go it's like what's the difference between the two?
I'm computing an app engine. Yes, I'm going there. That's what I'm starting with app engine. So the app engine is fully managed what? Platform service frameworks. Now you don't have to worry about the infrastructure. So Google manages the infrastructure for you. That's what they do. You focus on your code and let Google help you manage the database. NoSQL database, in memory caching, loading balance, health checks, logging and authenticate users. You code your application to take advantage of this. You just code your application to access data, just like you coding to them to access the services. And what it does, your code take advantage of these services, apps engine provided for you, and you scale up automatically. Traffic received automatically, it reduces automatically for you. So you only pay for those resources you use. Because Google manages them for them. So you only pay. You don't just go out. Some resources you don't even know you don't need them. You might actually need them just because you don't know. So if you don't know that you don't need them and you use them, you pay for them. When you have anyone who manages everything for you, you're actually fine with that. And you work perfectly. In Java 8 to Node.js in 2018, a second generation. We started launching IOA 2008, run on Python. From Python, it's run on Java runtime in 2009. Then it moves out in November 2011. It goes to Go runtime. You know Go language. Then it goes to PHP runtime in October, comes in. Then Java in 2017, and you have Node.js. Well, so we're going to talk about what? Compute engine now. So compute engine. So honestly, you asked about compute engine. So compute engine lets you run virtual machines on demand in the cloud. It allows you to run basically interact with your virtual machines. And what are virtual machines? Virtual machines are like computer. You have your own CPUs, your processors, you configure them. Just like you having a physical computer in the cloud. According to what you want, how many CPUs you want to run your system, you can use, you can say you want 25, 20 CPUs on the system. So it is Google's cloud infrastructure as a service solution, which provides maximum flexibility for people who prefer server, who want to use server for themselves. You want to build your own server online, you want to have your own computer server online. Virtual, and this is what you do with your virtual machines. Unlike the app engine that who does everything for you. Are you understanding now? Do you understand now? Okay, so compute engine is good for service, and you have your persistent storage, your networking, your VPC, you configure them, configure your firewalls, you configure your PCC, you configure your virtual machines, your VM instances to use to run it. So virtual machines, they have the power, generality of full-fledged operating system, just like the operating system you have in the cloud, and you are building your stuff on it. So you're building your house on your operating system and configure it. So you configure a virtual machine just like you do a physical server. You put in your CPU power, the memory, the amount of memory you want, the type of storage, the type of operating system, you configure it as well, and everything runs on Google Cloud. So machine types. You see, we have the defined machine types, the ratio of gigabytes of memory per V CPU, virtual CPU use. So you can decide to use a standard, decide to use memory, CPU. Don't forget that your CPU that means you are mount at the same time. You check your mount. So pick what is best used for you. So you have the custom machines. You can decide to specify the amount of memory and an amount of CPUs you want. So by configuring it, you can pick what you actually want, how you want your operating system, just like your operating system you want to be. Just like you're buying a computer, you have the computer has a 2 gig RAM, 500 gigabyte, and all that. Virtual CPU. Yeah. So this is the life cycle of virtual machine. You see the virtual machine for memory, then moves to the persistence disk, the root disk, where you can make a configuration of the root disk, the additional disk, You have your staging, the API address, the internal, external. You can declare your images, you can install images, your booting, you can put on it, then you can run on startup screens, then you can access SSH and RDB. SSH is just like you having your command prompt to run your cloud functions. So you can just, all your code goes via, all your coding via your interactive integration machine is used to via the SSH. Modify them, you can modify it, you can do a live migrate, then you can stop it if you don't want it, you can shut it down, you can terminate it, you can delete it. So you can do a lot of amazing things. So this is the life cycle of how it moves actually. So are you good? Any question here? Okay. So we have cloud functions. So cloud function is completely serverless. I made mention of it earlier on. We only have two aspects that are completely serverless, which is the app engine and the what? The cloud function. So the complete serverless is switch very environment function as a service. You can execute your code in response to the events which you actually want. Whether you want it once in a day or how many times you want. So who scales up with resources as you actually require? So you don't have a big issue with anything you're doing. You scale it up according to your resources you want, because it's very important for you to understand that your resources determines your what? Determines the price you pay. So you don't want to exceed your resources, you don't want to pay so much on the cloud. And that's why you need a cloud engineer to give you the appropriate thing you need to do when you are actually configuring your thing. So you only pay for the service that your code runs. So I'll proceed. So a Qwiklabs of just a better way of when it runs and on runtime days or start driver applications, and you only pay only when you code. That's Europe, the Asia, and the what? The US. So you can have US 1A, 1B, 1C. You have 1A, 1B, 1C, and 1B. Yeah, I'm correct. So then you have unions, groups too, West 1, West 2, and etc. So I still going to change you when I'm in the character section. So single project, multiple regions, which you actually wanted. Yes. And now you have the big Kubernetes. So Kubernetes actually allows you to run your containers as applications on cloud environment. So Google manage you under its administrative control. So it's just like you having a container which you build your applications. You can try to have another container, but at least one container when you are reading, when you are running, when you deploy your application, you have to have at least one container. So a single container. So you can decide to have, according to your maybe organization is flexible, they have different apps and they will not have to leverage on the control of what you want to build. So you can decide to have different containers and manage it according to your AIM privileges or what you want. So another example of how Kubernetes works is certain example of how you have WordPress, like a container, and you run your code, you run your website on it, you run your your apps, you install your website on it. Just like WordPress is just like a container of containing all your website inside it. Just that's how similar and then that's similar how Kubernetes work. So you think of a containerization as a way to package your code, and this is designed to highly portable, use resources very efficient, very efficient. And think of Kubernetes as a way to orchestrate your code in containers, just like I said. You orchestrate your code in what? In containers. And you must have at least one container to run your code. So Kubernetes engine is like an infrastructure, just like it's a service offering that gives you choice. It's not a platform that offering what building with what the developers have in mind. So it's built with what developers want, what they have in mind, the needs of what the developer wants and what they have in mind. Maybe they are facing core challenges of areas, and this Kubernetes, the big Kubernetes will actually solve that. So it makes it easier for you to orchestrate many containers, but you have to have a single container. So you have to scale them, roll out new version of them, and at the same time you can roll back the old version if things go wrong. So we have the cloud storage. I don't want to go too complicated. That's just how when it's big. So in cloud storage, just like we are talking about how to run your code, we also have the storage version of it. The storage you want, the storage version of your Google platform. On the storage part of Google platform, you have the cloud data stores. So this is how it works. You want to consider using cloud store if you need to store structured objects, or you need to require for transactions and SQL-like queries. You want to run your queries, you want to build something like image objects, or your website takes objects or URL, convert the objects, images to URL, yes, to objects. But at the same time, your website around something media objects. Do you understand? So you can consider using a cloud and store. So you can use big table, consider using big table. If you need to store a large amount of single key data, especially structured objects, you can use your cloud big data, big table. Then you can use your cloud storage. If you need to store immutable binary objects, you have binary objects, you're building applications that have immutable binary objects, you can use your cloud storage. Then you can use cloud spanner or your cloud SQL, depending on whatever you needed, whatever solve both of them are almost the same thing. It works, but just like one of them is going to be higher than the other. Do you understand? So if you need to have a full SQL support on an online transaction, like you are building a financial apps, processing systems and all that, so you can actually use the spanner if it's not too much. But if it's so much that it has moved into what we know as terabytes, cloud storage, cloud SQL takes terabytes. After terabyte, we have what? We have petabyte. What's the largest? Yeah? Yeah, what's the largest? What's the largest? Byte. No, not bigger byte. Bigger byte. It's Z. It's Z. It's zero byte. It's something around zero byte. And I told them about it. You go follow me on mission. You see around what the largest byte. So we have petabytes. I told you one is different because of the storage capacity. This one takes maximum of terabytes. While if you have a data that contains extended to petabytes, then you can actually use the cloud spanner to do that. So you have BigQuery as well. So you can consider using BigQuery if you need to interact with query online and you can actually scale it with petabyte at the same time. So depending on what you want, you have to know the exact use of what you want to use, application you are building, and how scalable your application will go. Then you can pick up the exact storage platform, the exact compute engine you're going to use, and at the same time you pick up the exact storage you're going to use. So both of them has to work together so that you will not be mistaken. Do you understand? So that's about that. So BigQuery between further between domains, the data needs to run more than exploring a vast sea of data. If you have a vast sea of data, that's why you see BigQuery being run, and we want to do ad hoc SQL queries on a massive data set. It's fully managed by Google, and you can scale it up to petabyte and low cost analytics as well. So if you hear about the BigQuery, you talk about this is what BigQuery does as well. So the question really is, it's really about the performance versus the cost, because there's different pricing structures. So you have to understand what you want your app is, how you want your app to scale the performance generally, and versus the cost of what you want to build. If you pick the wrong one, you have a light bill versus
Question. So, for example, if I plan to build an application and initially I targeted, let's say, 500 users, okay, and then I picked the one that works for that amount of, and then in with time, my users get to as much as maybe 3 million. So does that mean that I would have to pick another one, or they will just switch it for me and
Okay,
upgrade.
just I give an example of cloud storage and cloud span. Cloud panel takes what? Terabyte, isn't it? And they are all together, they are just like, they are not opposite, they are the same thing. Do you understand what I'm saying? But one is like just like they are switching from one to another. One takes the maximum of what? The terabyte, while the other takes petabyte, you understand? So when your application has automatically scaled, and you request for it in Google Cloud Platform to move it to cloud spanner, so it moves to petabyte. That's just it. So this is the cloud, beautiful cloud thing that we have here. So if you have any question, you can tell me. That's the end of my slide.
So, how do you become a cloud?
Okay.
How do you become a cloud engineer?
How do you do it?
Cloud engineer, what you need to do.
Awesome. That's a good question actually. So how do you become a cloud engineer? It's stages. That's the first thing I have to tell you. You have to start from, just like you see our master was saying, you have to start from the foundation, then just build the house on the top. You have to start from maybe your normal web, JavaScript, building. How do you become a software engineer? I'll tell you that before you can call yourself a software engineer, you don't call yourself a software developer. You are building apps. But before you can become an engineer, you would have been so familiar with cloud. There's a question I asked that was asked that how do you know that you are going to interview on an advanced level of your software development phases? When you start getting to an advanced level, it's when you work with cloud. When you become a cloud engineer, you become an hot cake. More international opportunity comes to you. You become outstanding because only few people are there and understand how this works because of this complexity and communication. So now, go back to how to get started. How to get started is that you have to do your normal, pay your bills, the normal deals, like from pay to intermediate. Get familiar with one of the languages, key language, Java, Python, because these are things that people see in the cloud. Whether you have Python, Java, Go language, and I think there's one language that I'm not called actually.
K.
K. I don't know about K, but they say the core language that really works well more on because it's actually what the platform they built. Do you understand? So the cloud around more of Microsoft, Azure, and all that. The DevOps engineer. So generally, there's cloud engineers too because they do a lot of around cloud. So like AWS, or you develop an expert in cloud, or you do around Microsoft Azure expert certification. Any other question? Any other question? For you to what? To get started in the cloud. So but you have to understand that you have been building apps, you are understanding how application works, SaaS, start from shared hosting, virtual private hosting and all that, then you move to the cloud. So how do you get started when you get to the cloud? You work with Qwiklabs. Do connect with Qwiklabs to actually to access the what? The console. So you can start from taking courses from Coursera, Udemy. So that's my recommend. I recommend Coursera for you. So you take courses from there and you get started. You take the up the last from there, then you get more familiar with how cloud works.
Okay, so my question is there a difference between cloud engineer and DevOps? Or are they the same thing? Or are they in levels? Maybe after DevOps they can come in cloud engineer or maybe regarded as the same?
They are similar. That's what I would do because the main thing is that when you call them DevOps, it's mainly because when you work on it's more or less like the cloud aspect of Microsoft aspect. So Microsoft aspect cloud engineer are going to be accessing working with Qwiklabs, my network. So I opened my Google Cloud console as I told you, my Google Cloud console. Qwiklabs on the right here. I copy my username. So, and I copy my password. I have a project ID at the same time. So I'm trying to access the Qwiklabs platform, and I accept the conditions. So now you can see that I'm accessing console.cloud.google.com. So I'm entering the Qwiklabs platform console. I told about earlier on. So I'm in Nigeria, in China. So I accepted my degree. So then I'm in the cloud. You can see my project name, how we walk through the resources, trace, the APIs. There's how an activity you are doing. You can see your activities here. I don't have any activities already. So I have my marketplace. Depending on what I want to install, I can search here. I can search whatever I want here. I can come to the billing, the API services, support, the admin and privileges. If you have an organization, they can give you privileges according to what you want, or a set of quotas, how the maximum amount you want to spend in a month, or basically the day, as well as the rules. Then you can go to your app engine here. You can go to compute engine. So in your compute engine, you can see your Kubernetes, you can see your cloud functions, you can access them via the store. So you click on VM instances. So you can come here. You can come here to see the storage that I told you about, like we talked about, big table, the SQL, spanner, the registry, the data transfer, cloud storage, and all that. So you can create instances here. This is what we call your virtual machine instances. So you click on create. So when you click on create, you can name your instances whatever you want. Let's say that the lab we are going through the lab. You can see the first objective was for us to actually create an instances and name it MC server. So now we create this. I'm just going to go through what process of how this works. So I told you that 3 different regions or data center that you can contact to. You have the US.
Yeah, that's.
So we have 3 major regions, which is the US region, which is the American region, the Europe and the Asia, as I told you. As you can see, you can create US law, one central, one day, then I create it. And you can see what is one C, one A, and F. You have the A, B, C, and F. So according to this lab, I think we're just using, we're creating for 1A. For 1A. So you can check your memory optimized and your VPU is 1.2, so terabyte. You can change it if you want to change it. Then let me see. You can go back to your 1.2 terabyte. So you can decrease just like I think the virtual VPU that was active, the memory. Then you can decrease, make sure your Debian disk, I know this is the same thing as you wanted. So for the storage aspect, you can do your management to see what you want to check. As we want to configure maybe your network aspect, this is where you configure them. You can change your IP here, you can change your internal and external IP, because if you don't want the external IP that you access what you are building for, you can click on none if you don't want it to show. But we are not going to do on that one for now. So you can check your disk here, you can check your security as well. So you can turn on your VPN integrity, you can lost SSH keys if you don't want it to work on the special machine you have created, and your management and other key stuff you have that we wanted to actually access. So you can find an API access action ID. So we can under here we can click on wherever we actually want it according to this lab. So we can click on what we wanted to actually do. We can filter it. We can set API level for each level, and we can change it to storage. We can change the set the asset level to each API. So we switch it to this. If there's any other thing we need to change, maybe it's a big query, we are doing the cloud and everything. So the storage is what we wanted to change to read on the right, and we create our virtual machines. I'm not going to get involved. I'm only creating the virtual machine. So I just want to get familiar with how cloud functions works. So you click on create, you see your server coming up, external server on now. So refreshing to see your virtual machine coming up. Network. So you can see. So you can activate your cloud here. You want to